Have you ever wondered what's hidden deep beneath your feet? I mean, really deep. We're not talking about subways or buried treasure. We're talking hundreds of kilometers down, past the crust, into the fiery heart of our planet. For a long time, we pictured it as just layers of molten rock and a solid iron core. But what if I told you there might be something else down there? Something you'd never expect. Something that could rewrite our understanding of Earth's geology and even life itself. Get ready, because today we're diving deep to uncover a hidden subterranean world. We all learn in school that Earth's water is on the surface, in oceans, lakes, and rivers. It makes up the water cycle we know and love: evaporation, condensation, precipitation. But recent discoveries are pointing to a much larger reservoir of water, one that dwarfs all the oceans on the surface combined. And it's not sloshing around in some giant underground cave. It's locked away inside a specific type of rock, under immense pressure and scorching temperatures. This mind-bending idea is often called the ringwoodite theory. Let's break it down. The Earth has layers: the crust we live on, the mantle below it, and then the core at the center. The mantle itself is huge, making up most of our planet's volume. Between the upper and lower parts of the mantle, there's a region called the transition zone, stretching from about 410 to 660 kilometers deep. Down there, the conditions are insane. The pressure is over 200,000 times what we feel at sea level, and temperatures can soar past 1,500 degrees Celsius. Under these extreme conditions, minerals behave in ways we don't see on the surface. One of the key minerals in the upper mantle is olivine. As it gets pushed deeper into the transition zone, the immense pressure forces its atoms to rearrange into a new, denser crystal structure. This new mineral is called ringwoodite. And here's the crucial part. Ringwoodite's crystal lattice is like a tiny high-pressure sponge. It has a unique ability to trap and hold water. Not as liquid, not as ice, not even as steam, but as hydroxyl ions, which are basically water molecules that have been broken apart and integrated directly into the mineral structure. So, how did we even figure this out? It's not like we can just drill down that far. The deepest hole ever drilled by humans, the Kola Super Deep borehole, only reached about 12 kilometers. The mantle is hundreds of kilometers away. The first major clue came from a very unexpected source: a tiny, dirty-looking diamond found in Brazil back in 2008. Diamonds are formed under immense pressure deep within the Earth, and sometimes they carry tiny mineral fragments called inclusions up to the surface with them. These inclusions are like geological time capsules, preserving a perfect sample of the deep Earth environment. Scientists studied this particular diamond for years, and in 2014, they found a microscopic inclusion of ringwoodite. This was the first time anyone had ever seen a natural sample of ringwoodite from Earth's mantle. But the truly shocking discovery was what they found inside it. Using advanced analytical techniques, they confirmed that this tiny piece of ringwoodite contained about 1.5% water by weight. Now, 1.5% might not sound like a lot, but remember the scale we're talking about. The transition zone is a massive layer wrapping around the entire planet. If even a small fraction of that zone is made of water-rich ringwoodite, the total amount of water stored there could be staggering, potentially 3 times the volume of all the world's oceans combined. This wasn't just a one-off find. The evidence has been building from other fields, especially seismology. When an earthquake happens, it sends seismic waves vibrating through the entire planet. By setting up networks of seismometers around the globe, scientists can track how these waves travel. The speed and path of these waves change depending on the material they pass through, its density, temperature, and composition. It's like giving the Earth a planetary-scale ultrasound. Researchers studying seismic data from deep earthquakes noticed something strange. In many regions, particularly beneath North America and East Asia, seismic waves would slow down significantly as they passed through the transition zone. What could cause this slowdown? Well, lab experiments showed that when minerals like ringwoodite are hydrated, meaning they have water locked in their structure, they cause seismic waves to travel more slowly. The patterns seen in the seismic data matched the predictions for a wet transition zone perfectly. It was a global-scale confirmation of what that tiny diamond had hinted at. We were essentially seeing these vast subterranean reservoirs with sound waves. So, where did all this water come from? The leading theory is that it was dragged down from the surface over billions of years through a process called subduction. Tectonic plates, the massive slabs of rock that make up Earth's crust, are constantly moving. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced to bend and slide down into the mantle. As this slab of crust, saturated with ocean water, descends, the increasing heat and pressure squeeze the water out. This water then gets absorbed by the surrounding mantle minerals, including olivine, which later transforms into ringwoodite, locking the water away deep within the planet. This concept creates a whole new picture of Earth's water cycle. It's not just happening on the surface, there's a deep Earth water cycle too. Water is carried down into the mantle by subducting plates, stored for millions of years, and can eventually be released back to the surface. How? One way is through volcanic activity. Plumes of hot mantle rock, potentially carrying some of this deep water, can rise towards the surface. As the pressure decreases, the water is released from the minerals, turning into vapor. This can contribute to the formation of magma and explosive volcanic eruptions, which then release that water back into the atmosphere. This deep cycle could act as a massive geological buffer, regulating the amount of water on Earth as surface over geological timescales and helping to keep our ocean stable. The implications are huge. The presence of so much water in the mantle affects everything. Water acts like a lubricant for rock, so these deep reservoirs could influence plate tectonics and the movement of continents. It lowers the melting point of rock, which is fundamental to the creation of magma and the volcanism that shapes our planet's surface. It could even be linked to the very origin of Earth's water. Was our water delivered by comets and asteroids, or did it outgas from the planet's interior as it formed and cooled? This discovery suggests a significant portion of our water could have been part of Earth's building blocks from the very beginning. This field of research is constantly evolving. Scientists are developing more sophisticated seismic imaging techniques to map out these water-rich zones with greater precision. Projects are underway to drill into subduction zones to better understand how water is transported into the mantle. Every new piece of data, every deep earthquake, and every rare diamond from the depths gives us a clearer picture of Earth's internal plumbing. So, the next time you look at a globe or stand on the shore of an ocean, remember this. The water you see is just the tip of the iceberg. Deep beneath your feet, locked away in a realm of unimaginable pressure and heat, there may be entire oceans worth of hidden water, slowly cycling and shaping the very planet we call home. It's a powerful reminder that there are still profound mysteries to uncover about our world, right under our feet. Thanks for joining me on this deep dive into Earth's hidden oceans. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more journeys into the amazing world of science. Let me know in the comments what other planetary mysteries you'd like us to explore next. See you in the next video.